Welcome back to another episode of the MRP Easy Manufacturing Podcast. In today's episode, we'll talk about quality control in manufacturing for small to mid-sized businesses. Let's get started. So, what is quality control? Quality control is checking your products to make sure they're built right before they go out the door. Manufacturers typically inspect at several stages. Some check incoming materials first, others focus on key production steps, and most do a final check before shipping. Audits are done at various parts of the manufacturing process to maintain quality standards. So why bother with quality control? The math is straightforward. Finding a defective part in your facility might cost $20 to fix or replace. Let that same part reach a customer, and you're looking at return shipping, replacement costs, and time spent handling complaints. That's easily hundreds of dollars. Customer satisfaction is one of the main drivers for the quality control process. Plus, you need quality control to meet whatever quality requirements apply to your industry. That could be ISO certifications, industry standards, safety regulations, or customer requirements. There's always something you have to comply with. When you keep up with quality checks, you deal with fewer crises and keep customers happy by producing high-quality products. What's the difference between quality control and quality assurance? People mix these up all the time, and honestly, the names don't help much. Quality control is what most people think of when they hear quality. It's the inspecting and testing you do to catch bad parts in the production process. You're looking for problems after they've already happened. Quality assurance is different. It's about setting things up so problems don't happen to begin with. Better production processes, training your people, and similar methodologies that ensure quality finished products. Which one should you focus on? It depends on what you're making and how you're making it. Some manufacturers inspect everything because they can't afford to let defects slip through. Others spend time on training and process improvement because they'd rather prevent problems than catch them later. Most companies do some of both. The trick is finding the right mix without spending so much on quality that you price yourself out of business. The importance of quality control in manufacturing. Quality control isn't just about catching bad parts. It's about keeping your business from getting a poor brand reputation due to the expensive mess that poor quality control management creates. Quality control is vital in the following ways. The business impact of quality control. Poor quality costs way more than most people realize. Sure, you might spend $50 fixing a defective part in your shop, but let that final product reach a customer, and you could be looking at hundreds in warranty work, plus the time your people spend dealing with complaints and returns. Then there's reputational damage. One bad experience, and that customer tells 10 other people. Good quality control flips this around. When customers know how good your product is, they keep coming back and they tell others about you too. Regulatory and compliance benefits. All industries have regulatory requirements to follow. ISO standards, safety requirements, customer specifications. There's always something. Quality control helps you prove you're meeting these requirements when auditors show up or customers ask questions. It also protects you legally. If something goes wrong and you get sued, having records that show you followed proper quality control methods can save your company. Operational efficiency. Good quality control actually speeds things up and can streamline your production processes rather than slowing them down. When you catch problems early, you don't have to stop everything to fix a crisis. You avoid the scramble to rework bad parts or explain to customers why their order is late. Quality control also gives you better information about what's happening in your processes. You start to see patterns and can fix issues before they become expensive problems. Your suppliers get better too when you give them feedback about quality issues. Cost of quality. Poor quality is a cost multiplier. It isn't simply the material and manufacturing time required to reproduce and replace the off-quality part. It increases administrative costs, paperwork, shipping, and many other cost items across the board. The cost of poor quality can include internal failure issues like scrap, reinspection, or disposal, and external costs of poor quality can double shipping costs in round-trip terms. Reshipping may also be more expensive as single unit or pallet replacement is often higher in cost than full truckloads. Now let's talk about some of the most effective quality control methods. You've got several ways to approach quality control activities. What works depends on what you're making, your budget, and how much risk you can tolerate if something goes wrong. Here are some essential quality control methods used in manufacturing. First is statistical process control and statistical quality control. Statistical process and quality control. Use statistical methods to monitor your processes. You track measurements over time and plot them on control charts to spot when something's going off track. Instead of just checking each part individually, you're watching for patterns that signal trouble ahead. This works well when you're running consistent production processes. It works particularly well in high-volume operations where small shifts upstream can cause big problems downstream. Next is the 100% inspection method. This is pretty straightforward. You inspect every part that comes through. It catches everything, but it takes forever and costs a lot. Most places only do this when a single bad part could cause serious problems, or when they already know there are issues with a particular run or supplier. Next is first article inspection. This is where you thoroughly inspect the first piece made when you start a new job, change a process, or use new tooling. The idea is to catch setup problems before you make a whole batch of bad parts. It's especially common in aerospace and automotive, where one setup error could ruin hundreds of expensive components. Benchmarks are designed to ensure consistency. Other ways to check quality control are check sheets and QC checklists. Inspection checklists are straightforward documents that tell inspectors exactly what to look for and how to identify deviations. They standardize the process so that different people check the same things the same way. Good checklists make training easier and help ensure nothing gets missed during busy periods. From my experience, the best ones include specific measurement requirements and clear pass or fail criteria. No guesswork involved. They're simple ways to maintain consistent quality. Next are Lean and Six Sigma principles. These are bigger improvement systems that include quality as part of the whole package. PDCA, which stands for Plan, Do, Check, Act, is a 4-step cycle for tackling problems. You plan what to do, try it, check if it worked, then act on what you learned. 5S in the Six Sigma principle is about organizing your workspace so problems become immediately apparent. Both work better when management backs them and people are willing to change their routines. Finally, there's root cause analysis. When something goes wrong, this is how you figure out why it really happened, not just what went wrong. You keep asking why until you get to the underlying cause that you can actually fix. Without root cause analysis, you end up fixing the same problems over and over, usually with the same defect results. Now, how do you actually conduct quality control? As important as quality control is, you need to have a well-defined process for carrying it out. Here are some of the fundamentals for implementing a total quality management system. Planning your quality control approach. Start by figuring out where problems are most likely to happen in your process and what would hurt the most if it got to customers. Don't try to check everything. That will overwhelm you and strain your resources. Pick the things that really matter for how your product performs. How often should you inspect? That depends on how much risk you can live with and what you can afford to spend. Maybe you check every 10th part, or you sample randomly, or you focus on certain steps where you've had trouble before. Implementation workflow. Set up inspection stations at a few key spots for testing products and raw materials. Most companies check incoming materials, then again after any operation that's caused problems, and one final check before shipping. Train your quality control inspectors so they all look for the same things and measure the same way. What happens when someone finds a defect? That's just as important to figure out ahead of time. Who gets notified? How do you document the problem? Do you shut down the line or just quarantine the bad parts? If inspection initiatives feel like extra work that gets in the way, people won't do it properly. Documentation and record keeping. Keep track of what was inspected, any problems you found, and how you handled them. You can use a basic inspection spreadsheet or whatever works for your operation. Manufacturing software with built-in quality control functionality usually provides the best price to functionality ratio. Either way, the point is having enough information to spot issues and trends and prove to customers that you're actually checking things. Quality control records also help you figure out if your quality system is doing what it's supposed to do. Additionally, repeated defects may signal issues with product design. Here are some quality control tips and best practices for small manufacturers. After working in manufacturing and food processing for over 3 decades, I've discovered 8 quality control tips and best practices that work effectively. Apply them conscientiously, and your manufacturing process will improve significantly. Start with the basics. Focus on critical quality characteristics first. Here's something I learned the hard way. It's almost impossible to track everything all at once. It's inevitable that something will get lost in the confusion. Find the most important issues, concentrate on them until they become routine, then pick a few more to work on. It's often the best way to start quality project management. Build quality habits into daily operations. Train operators to recognize quality issues. Don't expect them to know what to look for intuitively. Not everyone has an instinct for quality issues. Work with your team until looking for problems becomes second nature to them. Make quality everyone's responsibility. Involve production staff in quality decisions. Most manufacturers and food and beverage processors have a dedicated staff for quality control, but don't expect them to be everywhere at once. Your production team should know what to look for and be able to inform your QC department immediately when issues arise. Create feedback loops between shifts and departments. Establish clear quality expectations and devise a way for efficient communication, even between shifts. Information from one shift needs to reach the next. That might include a debriefing session between shifts or production runs so the incoming team members know what to look for. Balance thoroughness with efficiency. Choose appropriate quality inspection levels for different products. Not everything is critical. Use risk-based approaches to focus efforts. Managing quality costs without compromising standards is important to meeting customers' needs, maintaining profit margins, and protecting your brand reputation. This will vary between product types, so look for areas where absolute perfection isn't necessary. Learn from quality issues. In my years in manufacturing, I've seen how blame culture actually makes quality problems worse. Treat defects as learning opportunities, not reasons for reprimand or blame. Share quality lessons across the organization to get everyone on board with both quality control, product, and quality assurance process. Build institutional knowledge about common problems by tracking them, recording them, and perhaps creating an instruction manual. Memories fade, written instructions last. Supplier quality management. Not every quality issue is your fault. Setting quality expectations with vendors is crucial for quality control. You can't create a quality product if the raw materials coming in are subpar. Incoming materials inspection strategies ensure that parts, components, or ingredients are acceptable before they even leave the receiving area. Finally, build partnerships for continuous improvement with all your suppliers. Consciously and conscientiously bring your suppliers into your quality control ecosystem. Good practices influence everyone in the supply chain. When you work with your suppliers to help them improve, everybody benefits, and everybody is happier, especially your customers and stakeholders. Now let's talk about using manufacturing software for quality control. For small manufacturers, buying separate quality management software often doesn't make financial sense, especially when you're already running manufacturing software that can handle essential quality control. What's the difference between integrated and standalone quality management systems? Standalone QMS software can cost thousands per month and requires separate training, data entry, and maintenance. That's a tough sell when you're already managing product development, inventory, production, and purchasing in another system. Integrated quality control features in your manufacturing software means one login, one database, and one system to maintain. Your quality data automatically connects to lot numbers, purchase orders, and production records without manual data entry. Sure, integrated systems might not have all the fancy features of dedicated QMS software, but most small manufacturers just need basic inspection workflows, hold procedures, and some quality reporting. The specialized stuff often isn't worth the extra cost and complexity. Essential quality control features in manufacturing software. Look for systems that can put incoming materials on hold for inspection and track which lots passed or failed. When goods show up for inspection, you want to get notified automatically. You also need to handle rejected items, either create rework orders or write them off without switching to different software. Sometimes defects slip through. Traceability is huge here. If a customer calls with a problem, you need to track that part back to where it came from. Which supplier sent the material? What date was it made? Which production run was it part of? Good reporting shows you patterns over time. Maybe one supplier keeps sending bad materials, or a particular operator misses way more defects than others. Here are some final implementation considerations. Don't pick software that's much more complicated than what you need. If it takes your people weeks to figure out the quality features, something's wrong. The best systems make quality control feel like part of what you're already doing, not some separate thing you have to remember. Your team should be able to learn it in a few hours, not several days. Also, watch the costs. If adding quality features doubles what you pay for software, you might be better off sticking with paper checklists and keeping good records. That wraps up this episode of the MRP Easy podcast. Thanks for tuning in. For more information, go to mrpeasy.com. See you next time.